transmitted from radio transmitters all the time. This one is sending them out now in all directions. And just like all electromagnetic waves, they travel in straight lines and carry energy. This miniature radio transmitter is pumping out radio waves now. Engineer David Yates wanted to prove to me they carried energy.
Here I am with a bulb lighting in space, no batteries up my sleeve, no wires joining me to anything, and yet the bulb's lit. It does look a bit like magic. It isn't magic at all. The electromagnetic wave is in space. They're quite strong because I'm close to a transmitting aerial, but nevertheless, I'm extracting energy from it and lighting the bulb. It's as simple as that.
You couldn't do this at home, as it only works with a transmitter like this. But huge radio transmitters can be seen all over the country. This is to make sure we can all tune in and pick up the radio waves. But to be able to pick them up, you have to have an aerial, and of course equipment to receive and convert the radio waves into something we can hear. These days, radio receivers can pick up a huge range of radio wavelengths simply at the press of a button. And their wavelengths can vary from a few millimetres to over 100 kilometres.
Look outside.
Part of David's job is to make sure we all get good, strong radio signals. But he wanted to point out that it's not only radio signals that are carried on radio waves, but also television signals.
The television aerials. People get confused about the fact that television sets pick up radio waves. I mean, that's the way the words are used. And in this case, they're picked up by this aerial, which is pointing in the direction of the transmitter. Let's see what's on your set today, then, Helen.
David wanted to see if I was receiving a good television signal, so I switched on and got a real surprise. Believe it or not, it was one of the series, and there I was. It was weird.
You know, it seems really funny seeing yourself on TV.
Well, what we're picking up now is quite a good, strong signal, because the aerial on top of the set is pointing along the line of the signal direct to the transmitter. If you turn the aerials in the wrong direction, you get this, which we call snow. Not very nice, is it? Now, if I turn the aerial back again, you'll see that the signal improves, the picture gets better. I turn it slowly, and lo and behold, back in the direction of the transmitter. Very nice picture now.
That had put concerning radio waves. But there are even more waves we use around the home. We all know what this is.
A microwave oven.
Microwaves are part of the spectrum, but in this case we're using their energy to heat and cook food for us. And this chart shows how we use just one area of the spectrum at the radio end to carry information for us, whether over long or short distances. We've seen many uses of the waves in the electromagnetic spectrum, and now it was time to get back to the rave, as I knew they were going to use many parts of the spectrum that night. There were plenty of lights and light waves, of course. But I'd heard the security people were relying on radio waves.
Hi, I'm Helen.
Hi.
Can you tell me the kind of things you're using for security tonight, please?
Well, we use walkie-talkies. We've got to communicate with people on the front gate. It'd be impossible to do my job without radios and radio wavelengths, but I must get on with it. OK, thanks. Hello, Kevin.
Everything's OK in the funfair area, Claire.
So that was radio waves. But I'd spotted another source of light, lasers. It was quite a climb to meet the guy organising the display.
Made it. Can you tell me a bit about lasers? What makes them so special?
Right. The reason that lasers are so special is they produce a very, very tight beam of light in a narrow wavelength. Well, tonight we're actually doing a laser display, which is these nice patterns, though, that they'll show up in the smoke, so it looks almost like that it's a solid shape, a solid mass of light actually floating in the air.
I was really looking forward to seeing all the laser and light displays. It wasn't long before people had started to arrive. But security had one more thing up their sleeve. All the tickets for the rave had been printed with special ink, which glows under ultraviolet light. If it didn't, they could tell it was a fake. Hundreds of people had turned up. The lights all seemed to be working, and all I needed to do now was simply join in. So next time you're out and about, think about all the thousands and thousands of electromagnetic waves whizzing past us all the time. In some ways, we're lucky we can't see them all, 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 see them all.